Hey everybody, so welcome back to video part 2 of Dash 2.6.0 release. In this video, we are going to focus on the background callback. We're going to do a deep dive, and Chris is going to explain to us why it's so important, how to use the background callbacks, and anything else that has to do with the background callback. So if you want to know or understand more about the other features, don't forget to go to video part 1 to hear about that. Chris, to get us started, for those who missed maybe part 1, why would someone want to use or need to use the background callback?
Mm-hmm. Yeah, so there's kind of two ways to think about it. One is avoiding timeouts. So when you deploy your application and you're using GUnicorn, you're deploying on a platform, there's often a server timeout error that you'll see if your application callbacks take longer than 30 seconds. And this is a network request timeout. And in the world of web applications and websites, it's pretty common in standard practice to have a timeout error within your servers because sometimes requests can hang for an unknown reason. And having this sort of timeout error uh, prevents or stops requests that are hanging so that they don't hang forever and just and prevent other requests from coming through. So having a server timeout error is a pretty common practice in website and web application development. Now, for Dash applications, a lot of applications are running really long running computations or fetching a lot of data and processing that data, and it can take a long time. So it's pretty common to run into that 30-second timeout issue. The way you get around this, that's sort of the standard architecture for scalable websites, is for any requests that take a long amount of time, you add it to a queue. And that queue will run the requests one at a time. So if there are multiple requests that are coming in, say you've got a button and you press that button and that button fetches a ton of data and then it runs a really complex model that takes 2 minutes. And you've got, say, 5 to 10 people visiting your application and they all hit that button. Instead of um, uh, trying to run all of those requests in parallel across all of those 10 people, um, the background queue will run the requests one at a time. So it'll put it in this queue based off of the order that the button was clicked. So the order that the job was submitted. And that enables you to, it's architected in a way that it avoids this 30-second timeout where the request might still take 5 to 10 minutes um, in order to return results to the user. But from a networking perspective, we're not holding that request open for 10 minutes. We're submitting that there's one request that happens under the hood to submit the request, and then subsequent requests that are happening to check to see if that job has finished in the background queue. So from a network perspective, all the requests are very short. They're all taking less than a second. And that enables us to avoid that network timeout issue. But it also enables us to scale. So if you have a Dash application, you're going to set the number of workers when you deploy that application. And you usually set that in the GUnicorn command with the like -- workers command. And that'll set the number of CPUs that are available to process requests at any given moment. So if you go back to that example of a button and you click that button and it takes 5 minutes to run, and your application is deployed with 4 workers, then if somebody visits your application or 4 people visit your application within 5 minutes, then all the CPUs are going to be busy processing that request with regular callbacks. You've set 4 CPUs or 4 workers to process requests. There have been 4 callbacks that have been fired by those, one callback by each person visiting the application. And very quickly, all 4 workers are going to be busy crunching numbers. And so
So
if a
now if a fifth
person
person comes,
exactly, yeah, the application is going to be unresponsive. They won't even see the application come up. It'll just be like a blank screen in your web browser, And after 30 seconds, you'll get an error that'll be like a timeout reached.
Which you really don't want, right? You hope that your app is going to be used by more than 4 to 5 people, and you don't want the sixth or seventh person to just see a blank screen. That'll be very bad user experience.
Yeah, exactly. So the way you solve this is you either add more CPU, so you add 10 CPU or 10 workers. But often we're working in CPU constrained environments. The servers we're deploying to only have so many CPUs. Adding more CPUs will cost more money. There's also, a limit. If you've got 100 people or 1,000 people, you're not going to want to deploy on 1,000 CPUs. So the way you work around this in sort of traditional software development is you submit these 4 tasks, each one of them to a background queue, and they will run one at a time. So for that first person that clicked the button, they'll see the result come back in 10 minutes. The second person, if they click the button like 1 second after the first person, then it's actually going to take 20 minutes for them to see the result because the first job will get run, return the results to the first user, and then the next job will come up and it will run and then return the results to the user. So it'll take more time because you're running things in a queue sequentially, but nothing will error out. And new people that are visiting the application will be able to see the app. There might be other parts of the application that can remain responsive that are running with regular callbacks that take less than 5 seconds. So all of that will still be responsive. And the loading screen that we show with background callbacks, where we show a progress bar, those will update and inform the user how long things are taking or whether progress is being made or not. So overall, it provides a better user experience that is inherently more scalable.
Yeah, just from you and I talked about this a couple of weeks ago, and I really, really liked the example you gave me. That made me understand this fairly quickly. Is that I when I go into a website and I click a submit button because I want to purchase something or whatever, and I get an alert that says, "Great, thank you. An email has been sent to your email address with the following receipt." I go to my email address and nothing is sent. Like I said, "Oh, you're lying because you didn't send me anything." But now I understand. They were probably using something equivalent to a background callback, and so I'm just in the queue. I may be the second one or third one. Eventually, I'll get it. But this system that they've implemented means that other users can use the website without it crashing.
Exactly. Yeah, this is like the key to scalable websites. It's a very common practice in web applications. And in that particular example, sending an email can take a few seconds. So even when you sign up for a new service and you click sign up and then a confirmation email is sent, because that can take a few seconds, you basically have two options. You can architect your website so when you click submit, it's loading for like 5 seconds, which feels like a really long time. And you might feel like something is broken. Also, it's holding that request in that CPU like hostage,
Right.
while it's waiting to send that email. Or you can say, okay, we're sending the email, you submit it to a queue, and then that queue runs things one at a time. And so almost every scalable website, that you interact with is using this architecture. Um, at the very least for email sign up flows.
Great. And so if I want to use a background callback starting with dash 2.6.0, where should I start? What should I do?
So first off, visit our documentation. We've got a full dedicated page on background callbacks. It's really in depth, shows a bunch of examples. But the summary is you're going to set background equals true within your app callback signature. So before, with long callbacks, you would use a different callback signature called long_callbacks. With this new version, you just set background equals true inside your callback signature. You also need to configure where the results are being stored. And we've got two options available. There's this disk cache option, which is available for development purposes. It's a little bit easier to set up. And then we've got like the production grade, the version that you need to be using when you deploy your application that's using Redis. And so you'll need to set up, which one of those two options you want to use. And then if you're using Redis, you need to provide the Redis URL to configure that. So there's a little bit of boilerplate used just to configure the way that the background callbacks, and the queue are being set up and run.
This just as a brief summary, this cache is really just used when you're developing, just to test it out. But you're recommending not to use this in development because it actually doesn't queue, right? If you really want to deploy your app and make sure it works with multiple users, you want to use Redis and Celery, which are also open source, right?
Yeah, that's right. So disk cache, you don't want to use in production. You can just use it for development. And by development, meaning that when you write background equals true, like your code will run. And disk cache itself isn't, that method isn't actually running a queue. It's opening a separate thread or a separate process and running it there. Um, and you more as multiple people visit the application, multiple sub processes are going to be opened up, which is going to end up using more CPUs, which like doesn't so you don't get the benefits of using a single queue where you're controlling the number of CPUs that are set, and you aren't like ballooning the number of CPUs as more people use it. So the disk cache method is really just used for development purposes. It's not actually running a queue. It's also saving the results of the callback to a file. A lot of deployment platforms are Docker based, where if you save to a file, that file is saved in the Docker container, which is ephemeral. So if you deploy a new change, then that result that was saved in the file isn't available in the next deployment. So there's a lot of reasons why it's not suitable for production. We just made it available for development in case you have difficulty running Redis on your local workstation.
Perfect. And what if, like, the background equals true, background callback to activate that sounds like a so powerful. Why can I just not always set background equals true in every callback that I have?
hmm Yeah, there's a little bit of overhead with using background equals true, where what's happening under the scene is there's a separate process that's going to be running, and that process is going to be running your callback code one at a time. And the way this works under the hood is with Celery or background callbacks in general, and the way this works with Redis is the main web application will um, submit the task to the background callback or to the background queue. And the way that it sort of submits the task is it's going to take the input arguments of the function that it needs to run, and it's going to serialize that. So it's going to convert it to some text or some binary format. And then it's going to save that in Redis. And so Redis is an in memory database. And you can kind of just think of just like a regular Python data structure, like a list or like a dictionary. Redis is sort of like that. So it's going to create this in-memory object. You can think of it like a Python list, and it's going to add something there. So it's going to take the input arguments of your function. It's going to serialize them to a string or to some binary format. It's going to add it to this list in Redis. And that process itself, there's like a little bit of overhead there because you're converting the input arguments to strings and then you're transporting it over the network. That network might be an internal network, it might be very close, but there's a little bit of overhead to Redis. And then it's going to store that data in Redis. And then this separate worker, this separate Celery task is polling Redis and is checking for this list. And it's saying, hey, is there anything in this list? Is there anything in this list? I just finished something. I need something else to do. Let me check this list of tasks and I'll pull something out there and then I'll run that task. And so there's sort of a little bit of overhead on either side of this. That's sort of like the inherent complexity of running a background task or a background queue. So if your application is fast enough, your callbacks are fast enough, and it's scaling, they take less than 5 seconds, I would say, or if they take longer than 5 seconds, but you don't have many concurrent users at once, then you don't really need that extra overhead, both for development, for the performance, but also for when you deploy your application, you don't need to set up these other things like Redis. Um, so that's kind of the main reason. I think you could set background equals true and it would work fine. There's just a little bit of overhead. The performance hit wouldn't be that big. But it'd be kind of like some unnecessary extra like complexity.
Cool. And for those who are um, where you just what you just mentioned, who don't have too many users, and maybe the callback is not running doesn't take too much time to run, and they want to figure out how many CPUs they have, or maybe they would add one or two more CPUs because that would be the solution. How can they find that? Where can they look to see how many CPUs are available, and how can they purchase more? What do they do?
Yeah, so the CPUs will be set with that gunicorn command. When you're deploying your application, um, the command that you want to run when you deploy your application is something like gunicorn app colon server hyphen hyphen workers and then a number. And the number there is the number of Python processes that are going to be run that will be serving your application, and that is going to be equivalent to the number of CPUs that your application could be using at once. So if you want to use more CPUs, you increment that number from like 4 to 6 to 8. And then you have to ensure that the application, the platform that you're deploying to, has those number of CPUs available. And that's going to be very platform dependent. On Dash Enterprise, the platform itself is often deployed in environments that are over provisioned. So they've got some spare CPUs available. So it's safe for you to increment that number. And many applications are running on the same platform where there's plentiful CPUs for new applications to be run. And
Perfect.
the same goes for the background queue itself. Um, you can set there to be more than one worker processing these tasks in this queue. So if there's 10 tasks in the queue, instead of a worker picking things off and running them one at a time, you could set there to be 4 different workers, and they're all looking to this queue, picking things off, running them, and then picking things off, running them. So if you have an application that has long running tasks that's serving a bunch of users, you might have maybe 2 to 4 workers that are running in gunicorn to serve the main Dash application. You might have 2 to 4 background Celery tasks that are Celery's the Python process that's running this background queue. Um, and you might be tweaking those depending on how much of your application is running these long running requests versus whether it's just one callback or whether it's a central feature of your application is doing this long computation. To set more workers on Celery, the flag I think is called concurrency. So instead of hyphen hyphen workers for, it'd be hyphen hyphen concurrency for.
Perfect. Thank you, Chris. That's a great explanation. Really helped me, and I'm sure all of our viewers understand the background callback better. And so, if they want to get started beyond the announcement post that they should check out below on the forum, as you said, they can go to, and they should go to the Dash Docs where we have much of what you said in there. Anything
That's
else you want to add about the background callback or to our viewers?
Yeah, I think the thing to know about running this in production environments is you're going to need a environment for that can run multiple commands, because instead of just running a single command, gunicorn app colon server, you're going to be running 2 commands, gunicorn app colon server that might run in one container, and then a Celery command that's running the Python process for handling the background jobs. So there'll be 2 Python processes that'll be running, often in separate containers. That's how it works on Dash Enterprise. And then you'll also need a Redis database running that sort of stands in the middle, network access to from both of those commands to both of those processes or containers to Redis. That's how the communication happens. If you're using Dash Enterprise, you can add Redis to your application in one click with the UI. So I'll just show my screen really quickly to show folks how that works.
Okay, you're good.
So in Dash Enterprise, there's a button here to your application where you can click Add Redis. This is going to add a Redis database to your application. It also makes the Redis database available to the workspace environment, which is the onboard IDE or code editor, so that if you can't run Redis on your own local workstation on your laptop, you can use the built-in workspace editor, which will have Redis available within the environment on Dash Enterprise. And this is kind of one of the many reasons why we're really excited about the Dash Enterprise platform and felt like there was a need for a dedicated platform for Dash applications, was because things like this, running background jobs, running background queues, require extra complicated infrastructure. And that stuff is really difficult to set up in traditional IT environments within organizations. And so we architected Dash Enterprise to provide all of these different types of infrastructure capabilities so that you can leverage these features within your organization and be able to use them yourself without needing to rely on your IT department to set up these services for you, which can be really can take a lot of time and be really complex.
Which is why I also heard from some community members how they want to learn more about the how to activate or implement the background callback with Dash Enterprise. Just makes things a lot more easier.
Hmm.
Uh,
Yeah. Yeah, and there's nothing, Redis itself, it's open source, it's free technology, it's available for you. The platform, Dash Enterprise platform, is making it much easier for you to use in development and in production environments.
Great. Thank you, Chris. I appreciate this deep overview. Viewers, don't forget to ask your comments, ask your questions below if you have any questions. We'll make sure to answer them. Check out our forum post and our Dash documentation. Thank you for joining us today, and keep on building wonderful Dash apps.
Thanks all.